Hello, I'm Stefan Greber. I'm the engineering manager for the LXC team at Canonical, and also the project leader for LXC, LXCFS, and LXT. This talk is going to be about the past, present, and future of LXC, where we're going to be looking at a bit of the history of containers, system containers, and just in general what LXC is about. To start off, let's go look at what containers are. So, containers are OS level virtualization. That means that all containers share their kernel with the host system. It brings in some interesting behavior. For example, you can run a completely outdated version of a Linux distribution inside a container on a modern system. And that distribution will now run with a much more recent kernel, including things like security fixes and new performance improvements. Containers come with bare metal performance. There is no virtualization overhead whatsoever. There's no fake BIOS, no fake hardware, none of that. Anything that is passed to a container from the host system gets you direct access with no overhead whatsoever. It also brings in the ability to share devices amongst multiple containers on the system in ways that is not possible with dedicated hardware or even with virtual machines. There are a number of different types of containers on Linux. The one most people will be familiar with these days would be the application containers. That's things like Docker and Kubernetes, where containers are used to ship a specific service, and all of its dependencies in some kind of bundle to a variety of systems. Those containers will only run typically a single process or single service and be usually pretty stateless. Then you've got the containers that LXC really is about, which are system containers. Those look and feel like virtual machines. They are long-lived, they are persistent, they run multiple services and daemons and everything, and they're really meant to feel like a totally normal Linux system. In fact, you might have used those in the past, not even knowing that you were inside a container. And the third type, a bit less usual, less visible, they would be embedded containers. And what we call embedded containers here are other pieces of software using container technology to enhance their security. The most common example of that would be web browsers, where they tend to run their rendering threads within effectively containers. So using namespaces and using seccomp, sandboxing, and those kind of features to completely isolate the rendering threads from the threads that have access to user data or have access to the network. Now, focusing on system containers, they are the oldest type of container technology out there. We're going to be going into more details around the history in a tiny bit, but they've been around a long time, since late 90s, early 2000s. They behave like community standalone systems, as I mentioned. There's no need for the software inside of those containers to be container aware. Everything, they're effectively like normal Linux distributions. You start them, they behave exactly like a normal system. And you can SSH, you can install your packages with normal package managers. They really feel and act like virtual machines. They're very low overhead because they're containers. So unlike virtual machines, and they're very easy to manage. Everything shows up as just a bunch of processes on the host system. And that's pretty much it for system containers. Like, if you don't know about them, you might just think it's a virtual machine, except that you can cram thousands of those on a system, whereas you would run out of resources with just a few hundred virtual machines. Now, what's LXC? So LXC is primarily a system container manager. I'm saying primarily because there's technically support for OCI application containers within LXC, but it's a less common use case for it. It's low footprint, so it's suitable for embedded environments. It's written in C, and so in those environments, it's possible to run LXC with just a few megabytes of RAM. It's open source. The library itself is LGPL, and the tools are GPL. It provides both a set of tools to directly create and manage containers, as well as a library that downstream projects can use to create and operate their own containers. It integrates with LXCFS, which is a file system that we also maintain. That file system is done using Fuse, and effectively provides an overlay within the container for files that show resource information. That means that if you apply, say, memory or CPU limits to a container, LXCFS will make sure that files like meminfo and CPU info show what the container has access to instead of the system-wide information. LXC containers can run as either root or unprivileged. So in the unprivileged case, it means you're actually creating and starting the container as an unprivileged user. That's what some other projects might refer to as rootless containers. It's effectively the same concept. LXC manages the usual set of container primitives. As a bit of background there, there's no such thing as a container in Linux. It's effectively a user space fiction that combines a number of kernel features to give the experience of a container. So LXC achieves that by using namespaces, the Linux security modules. It drives a number of network features, also drives a number of storage features like ZFS, LVM, and others. It drives a number of file system features, allowing for bind mounts, ID mappings, those kind of things at the file system level. And it supports advanced features like system call interception by using seccomp. LXC itself is used by a number of downstream projects. Personally, I'm running the LXD project, which is like a newer container and virtual machine manager that uses LXC to run its container side of things. Proxmox similarly uses LXC to drive their containers, and the same is true for OpenNebula and for many, many others. LXC has been around a long time, well over a decade at this point, and so it is very tightly integrated with a lot of different projects. On top of publishing LXC, LXCFS, and NextDay, we also publish daily images. So we currently build a total of 24 Linux distributions across, meaning around 106 different releases. We do that on 6 different hardware architectures, which leads to about 424 or so different images that are built daily on our platform. Those images are made available to any LXC or LXD users through public image servers. Now, kind of circling back and getting back into the history. So looking at the history of containers across all different operating systems, the general concept kind of came up right at the end of the 90s with folks from Virtuoso pushing for the concept of containers and starting to really talk about it. The first implementation was not on Linux, but was instead on BSD, with BSD jail starting in the 2000s. That was pretty shortly followed by the first Linux implementation as Linux vServer. This was not mainline, so it was a big patch set on top of the Linux kernel at the time. A few years later, Solaris implemented Solaris zones that were quite closely related to the BSD jails. It was effectively the same concept. And a year later, the OpenVZ project, so OpenVirtuoso, started on Linux and also offering kind of what was the best implementation of containers at the time, but it was also done through a massive patch set on top of the normal Linux kernel. In 2008, the LXC project started. The goal of LXC was to drive containers solely through features inside of the mainline Linux kernel, so not needing any patches. And that's what we've been doing ever since. Then come 2013, Docker showed up, and at the time was using LXC to run application containers. That has then changed, and they're now using containerd and runc to run their containers. And in 2014, we considered containers on Linux to be solid enough. It was time to rethink the user experience. And so the LXC team created the LXC project as a way to rethink the container experience on Linux. Now, looking for LXC specifically, as I mentioned, LXC started in 2008 with LXC 0.1. It took about 6 years or so to get to a point where we were comfortable having production users really running it. So the first long-term support release for LXC was in 2014, and we've then followed that by another LTS release every 2 years after that, with leading to 2022, where the LXC 5.0 release is upcoming in the next days to weeks. On the Linux front, as I mentioned, LXC was really tied to whatever was being upstreamed. We've been pushing for the kernel development aspects as well as the user space, and always kind of updating LXC whenever something would land upstream. We consider containers to be effectively feature complete, as in good enough to replace OpenVZ as of 2014 with the Linux 3.13 kernel, because that was the second kernel to have user namespaces and when things kind of stabilize as far as security around that feature. That doesn't mean that we've not been actively working on stuff since 2014, quite far from that. On the kernel side, new features were implemented for PDFDs to avoid a bunch of risk conditions in the proc file system. ID map, VFS is quite recent, so the ability to mount file systems with specific maps in place. I mentioned system call interception already. That's something that was added to seccomp over a few years. And other namespaces were also added around the cgroup namespace and time namespace in the recent years. LXC always always tries to be the first one to support those features, and so that's the primary focus of our releases these days. Now, looking ahead, what can you expect in the next few years? So the bulk of that is, again, kernel work that we will then implement within LXC in user space. I mentioned system call interception. That's something we're quite focused on recently because it allows for much safer containers by running containers with far less privileges that have just slightly elevated privileges on a few system calls through interception. So the seccomp side of things and the LXC side of things have been done for a little while, but now we are actively using those features, and there's a good chance we'll eventually find some kind of shortcoming or missing feature that we'll need to tackle. The cgroup 2 migration is still in progress. We do have pretty good support for it in LXC, in LXCFS, and in LXD, but it's still a bit of the transition is not quite done. There's still some gaps. It's still not fully feature parity with cgroup 1 as far as the user experience. So we expect some developments there. There's still a bunch of chats and talks kind of going around that. The VFS ID map feature is also quite recent, has been implemented in the past year or so, and we are still actively expanding that to other file systems. So right now, ext4, VFAT, XFS, BurFS, F2FS, and Fuse, I believe, are all supported, but there's ongoing efforts to add SEFFS, ZFS, and a number of others to the mix. The user namespace is also a feature that we quite actively rely on, that works pretty well in our experience, but that could be a lot easier, and we've got plans to try and simplify it and make it much more easy for others to adopt and make good use of, as well as dealing with potential issues when you're running multiple container managers on a single machine. Memory isolation, both through hardware and on the Linux side of things, has been quite a topic for the past couple of years. So that's also something we're looking into, the ability of having different page tables per containers, for example, or using some of the hardware memory security features like SVM or SGX. So there's quite a lot of stuff going on there. On the checkpoint restore side, that's also something that's always been quite interesting for LXC, but only works for very, very specific workloads. We expect it to stay that way, but there's still a lot of improvements that can happen there. And recently, there's been talks for things like checkpoint and restore of GPU state, for example. So quite exciting, quite a lot of things still going on. LXC is not a super fast moving project because it effectively works, but we're always adding new features as we see them land in the upstream kernel. And that's it for my talk. I am in the chat section if you've got any questions. On the slide here, you can see our website, the GitHub repository for LXC, and our community forum where you can go and also chat with us and ask questions. I hope this was useful to you, and enjoy the rest of your conference. Bye.